Welcome to a lesson on how to organize your memory to prepare for an assessment. This is a basic layout that I think will be beneficial for people no matter what topic you're in, is to note that the topic that the general unit that you're working on would be at the top, and then all the subunits, each section that you're working on could be based on if finance is what you're talking about. We had 5 topics in finance: basic compound interest, annuity, investing, and then annuity withdrawals. This is usually when you're working up to retirement, and then withdrawals are after you've retired, you start taking money out, and then loan repayments of every type. And so these are the 5 topics. Were simple interest, and I would suggest that you have a page that summarizes simple interest, jotting down some of the applications that you'd have in there and the formulas and the meaning of all the variables in the formula. We also covered regular compound interest. There's the regular compound interest formula. I use a T, sometimes that's an N up there instead of a T, but it's used, various different variables are used by different books and such. But anyway, have a little definition of when compound interest is used, or regular compound interest formula is used. Then we also studied annuity savings plans. And annuity savings was when you had scheduled deposits over time. The difference between that and a regular, just simple compound interest, this regular compound interest rather, was this is a one-time investment. And that should be noted. It's a single deposit. And this is when you have many scheduled deposits. It is an annuity savings plan, and that's also compound interest. And then annuity payout, where the money comes back. Now this is an example that, let's say on a page of your notes that you are summarizing each subunit, subtopic, that you kind of jot down when it's used. There's many scheduled withdrawals in this case, and you have the formula for that particular topic, and then the meaning of every one of the variables in the formula. So I highly recommend that you write all those down. We'll look at examples of each of these later. And then we had loan repayment plans also, and there's the same formula and the meaning of those variables in that formula as well. So if we go back to simple interest, this is B again, the kind of the summary of what simple interest is about and some of the possible applications. And then under that I would have several examples. Like here's an example for bonds under simple interest, and you can see I have an example problem. This is an example problem with kind of the how you'd set it up, what each of the variables mean from the reading, and then on the back of a little card, maybe this could be a problem on a note card, and on the back of the note card you could have the solution worked out. Similarly, you might want something with just an investment with simple interest, how long it takes for an investment to grow from 2,000 to 6,000. This gives a little explanation of that. The principal is 2,000. The interest, if you go from 2,000 to 6,000, that's 6,000 minus 2,000. That would be the 4,000 would be the principal, the interest that you'd be earning, right? And there's your 6%, and you're trying to find out how long it will take to do that. And then interest on a loan for only one period. Now that's another example. Now mostly loans have compound interest. Loans typically are compound interest, and you make monthly payments to return that, and they compound as you go. But each individual month they calculate the interest using the simple interest formula. So if you owe a certain amount of money, let's say you've been paying on a loan and you owe $7,500, if the interest rate is 4.25%, that's an annual percentage rate, then to find the interest you just use simple interest, principal times rate times time, and notice times 1/12 if it's a monthly payment. Typically the 4.25, those are usually the annual percentage rate. You kind of assume that if it doesn't say APR, you can assume it's an APR for everything in this class that we do and in the book. So 4.25% APR, that's an annual rate, so one time is 1/12 of the year. But anyway, that's how you'd set that up. Just to have an example like that. Another possibility is cumulative interest, which we've done a number of problems like that. So there's just 4 examples that you could have for simple calculating interest, just basic interest in a non-complicated fashion. Then you'd have regular compound interest, an example for that. Again, this was the page you saw before. This would be a summary page, and then under that summary page I would have multiple cards that have various problems that would be applications of that topic. And then again, jot down, maybe write down a notes on why certain variables are assigned such. Like this is doubling time. How long will it take to double an investment at 8% APR compounded monthly? Well, that doesn't give you much information. So this is a good example card that you might have under just compound interest. It doesn't tell you what you're starting with or what you're ending with. All you know is you're doubling an investment. But that means that the account value will end up to be 2 times whatever P is. So you can make up numbers if you want for P and A, as long as whatever P is, A is double that. That's how you double investment, is your principal is doubled. So I just used quite simply 1 for the principal and 2 for what the amount would be after time. And then you can solve that for T. And again, on the back I'd have a solution to this. This would be on a 3x5 card under the subheading of compound interest. Then we'd have another topic, annuity savings plans. And this is when you have scheduled deposits over time and you're earning compound interest. So remember that the previous topic was compound interest, which was a single deposit, and this annuity savings are compound interest, but there's many scheduled deposits. So typically monthly, could be quarterly or annually. And here I've gotten the formula for that. And notice on this one I didn't write down right here next to it the meaning of all those variables, but you should on a card have that as well. So here's an example, finding the total value after making regular deposits. So here's one type of problem from this is you're making regular deposits. You're making deposits of $200 a month. You know your interest rate. You know how long you're going to do it for. So you're finding this total amount when you're done. And notice this formula. You've got your payment, you've got your interest rate and your compoundings, and you've got the number of years you're going to do that. Now, another example though, this is finding the total after making regular deposits. Now you're finding the payments needed. So that's another type of problem you could have in this topic. This one, you want to have an account value of $1 million after 40 years. You know the interest rate, and now they want to know what the monthly payments would be. So now you know the final amount, $1 million, and you're trying to find what the payment is. So that's another example that you should have on a note card to prepare for a quiz or test. And finally, another type of problem in this topic would be finding the number of years needed to reach an investment goal. Now here's where we want to save $15,000. We know how much we want in the end. It's for a down payment on a house. And how long would it take if you save $600 per month? So here we know the final amount, $15,000. We know how much we can deposit each month. We are given an interest rate, and now we're trying to find the number of years it would take. So you'd have to solve that. Of course, on the back you'd want to have that solution worked out. So there's 3 examples for saving in an annuity account. And I'm going to give you another video on how to solve all those with the TI-84. You can use the same application for all of the annuity and loan formulas. We can use the TI-84 solver. And here's and I would definitely jot this down. Here's just an example. This would be on a note card, making sure you know what all the meanings of all those when you plug something into a calculator, what those should stand for. Next, annuity payout plans. That's another investment. Notice this formula is slightly different. if you're writing a summary, make sure you write down all the variables. Give an example. Here's an example. Finding how much is needed to provide a regular income from an annuity. This is how much would be needed in an annuity if the account was to provide a $6,000 monthly income for 25 years at 4%. So we know our monthly income, we know what we want it to be, we know our interest rate, we know how long it's going to be, and now we're finding the total. The next example, it's how much regular income can be provided from a given amount in an annuity. So here we know what we have. We have $120,000, and now we want to find out what the payment could be, what kind of income we could get from that if we wanted it to last for 30 years. It wouldn't be a whole lot in that particular case, but again, on the back of this card, this is an example. You'd flip it over and you'd have the solution worked out, or you'd show how you do that on the TI-84 TVM solver. So there's just a couple of examples for an annuity payout, and now we go to the last topic of loan repayments. Now that's pretty much the same formula as the annuity payout, because an annuity payout is really the other company has borrowed money from you and now they're having to pay you back. And this is a case where you're borrowing money and paying it back. So the variables really stand for pretty much the same thing, but you should write those down. Again, make sure you understand them in the context of a loan. And then here's another example, just one example to find the monthly payments. If you know how much the loan is, if you have a $120,000 loan. So this would be finding monthly payments, which is just like exactly like finding the payout if you had $120,000 already saved. But anyway, this is other notes you might add is these are what the variables stand for, but this tells you what you put in the TVM solver also. That might be good if you're using the TVM solver to remind yourself to have a note card. Note cards that have all that information and the actual problems, examples done on the back of those cards. So finally, just in summary, if you want to feel that your brain is organized, this is kind of a filing system, if you will. This is like the finance drawer. Inside the finance drawer, inside the finance file cabinet, there's a drawer for simple interest with fairly a few folders in that of examples. Similarly, there's a drawer for regular compound interest, for annuity savings, for annuity payout, and loan repayment plans. So we have 5 drawers. And your brain actually appreciates this kind of organization because it's a little bit how your brain works. It likes to go to categories, and within those categories there are subcategories. Now, these do connect. If you look down here, these will all connect too. There's overlap. A lot of the variables are connected. So we don't really see how the neural networking in your brain works. But it does, you will appreciate having an organized layout in front of you. And you could actually lay out your summary pages just like this with cards underneath it, so you have it in front of you and you've laid it all out, and you can finally get your plan and prepared, so you're confident that you know what you're really looking at when you approach a quiz or a test. So that's all I have for now. I'm going to come back and give you another video on how to use that TVM solver for every kind of problem: annuity, savings, payouts, and loans.